Hello, I am R. Kishore Kanna, Assistant Professor, Department of Biomedical Engineering, School of Bioengineering from Bharat Institute of Higher Education and Research. In this video, I am here to give lecture on application of pattern recognition in medical imaging techniques from the course name called Neural Networks and Pattern Recognition. Pattern recognition is a module it is a system or a concept is being widely used in various domains for classification, for description, for detection, and for monitoring. And it has the ability to process and analyze and monitor and produce the result without any error, and it is highly efficient, and it has the ability to process the data within short time period, so it is fast processing, so it is being widely used in various domains. So according to biomedical engineering and biomedical domain, pattern recognition is a main tool in medical image analysis and medical imaging techniques. What is known as medical imaging? An image which is being obtained from the human body for diagnosis or for detection or for monitoring any defects in the human physiology or anatomy parts, that is known as medical image. For capturing the medical image and for analyzing the medical image, our pattern recognition is being widely used. It is being used in image analysis process after the capturing of the medical images like CT, MRI, SPECT, X-ray, etc. Like this, when the images is being captured by using the tool of pattern recognition, image is being analyzed without any data loss with various parameters. So in this video, we are going to see about what is known as pattern recognition and how the tool of pattern recognition is being built for using or analyzing the medical image in medical imaging techniques. Okay, first of all, we are going to see about a topic called histogram, which is being completely built upon the working methodology of pattern recognition. Histogram is known as a technique or a procedure which is being done for medical image enhancement. When you are capturing a bioimage or when you're capturing a medical image from human body, you can't analyze or you can't capture or gather the data from a normal acquired image. When image is being acquired, it should be processed and it should be analyzed for the clear or depth information from the captured image. For getting the clear information and depth information of that medical image enhancement is being used in that histogram equalization. Image histogram equalization procedure is being widely used, and it has been completely built with the working principle of pattern recognition. First of all, we have to know what is histogram. Histogram is a procedure which is being deal with the frequency and with the number of events occurring in an image. So plotting the graphs and plotting the ups and downs between the occurrence and the events is known as histogram. Histogram is a plot of frequency of event with the various occurrence of in the plot during the time period is known as histogram. Histogram and its image in histogram is a graphical representation. This is a technical word which describes the histogram. Graphical representation between the number of pixel and its intensity level. So difference between the number of pixel and its intensity level in the medical image will be graphically plotted and represented by the technique called histogram. And it plots the number of pixel for each intensity value. So each intensity will be having some value. According to that value, the number of pixel which is being captured in the medical image will be plotted in a graph plot that is known as histogram. So these are the example of histogram. How it is being plotted, what are the pixel will be plotted in x-axis and events will be plotted in y-axis. According to the events and pixels, according to the time duration, it will be plotted as a color chart or a normal pie chart. So by the graphical representation itself, we can explain about the intensity values as well as the number of pixel located in the acquired image of medical image of the human body. So by proceeding the histogram, we can read or we can have higher knowledge in the image which is being captured as the output image in medical imaging techniques. Okay, when the histogram is being plotted from the image, that image will be plotted as a sequence in matrix where it will be plotted according to the rows and columns. So when a set of data or set of a graphical representation is being plotted in a graphical background, it will be plotted according to x-axis and y-axis. So the plotted pixel value and intensity value will be recorded in matrix format as a rows and columns. From this rows and columns only, histogram's intensity and pixel value. So each intensity will be having different pixel value will be plotted in the graph, and it is known as graphical representation of image. That is known as technique of histogram. And now we have to know why. Now we know what is histogram and how it is being done. Now we have to know why the histogram has been done for the image enhancement. Histogram has been completely developed and constructed by using a pattern recognition. It has the ability to plot at same time multiple values can be plotted graphically, which can be visible and clear and easy for analyzing the image which is being captured. At same time, multiple signals is being plotted or multiple images is being enhanced. Histogram has the ability to deliver this multiple images at same time. For this process, histogram is being widely used. So at same time, multiple processing to produce the output within the short time period is the working principle methodology of pattern recognition. So histogram is being developed and constructed from the application of pattern recognition. And for what purpose is histogram has been done means identifying the contrast of the image when an image is being captured or when for example a patient is being examined by the CT image. CT means computer tomography image. Once the CT mission captures the patient human anatomy structure in all 360-degree, the captured image will be loaded as a output image. Once the output image is being generated, we can't directly diagnose or we can't directly plot the exact location of defect of that patient. For detecting the exact or for diagnosing the perfect defect, we will be using this histogram. So that the diagnosing or detecting the process will be starting from identifying the image with the contrast of image. By adjusting the contrast, by increasing or decreasing the contrast of the image, the defect or default of that part in human body structure which has been captured by the CT can be identified. So for this purpose, histogram has been widely used in image enhancement or in medical image techniques. And to find the number of object, how many parameters been recorded, how many structure is being recorded, what are the structures defects, and what are the response of the structure, and what are the actual status of the structure, and due to the structure, what are the health condition is being happening, or health condition is being having the facing the changes in metabolic activity or in immune system of human body. So this many number of objects will be obtained from the single graphical representation that is known as histogram. And third one is thresholding. By thresholding, you can identify each and every single intensity value and its properties called number of pixels. So each intensity value, which is being each intensity will be having some value, which is being captured by the CT or MRI or medical imaging technicians. When it is being captured to distinguish or to differentiate the each and every intensity plot, this thresholding is being widely done, which will be enhancing the value to be clear and to differentiate the each intensity value. Thresholding is being done, and segmentation will be processing between the count and intensity of the plots which is being plotted in the graphical representation. By aligning, by segmenting, by splitting the plots which is being plotted in a graphical representation, people can easily understand or easily read or easily gain the knowledge from the histogram about the exact status of the image which is being captured. So these are the need, and these are the function, and these are the process to be rectified or to be answered by using the histogram technique. Now we know what is histogram, how it is being composed, how it is being constructed, for what reason histogram is being developed, and what are the feature of histogram in the application of medical imaging technique is being clearly explained. Next topic is histogram processing. So histogram processing will be coming under the topic called digital medical image processing. So where and all digital medical image processing application is being processed to process a image with the graphical representation, we need the technique called histogram. So for providing that process, for providing the steps of process to plot the graphical representation between the pixel value and intensity value of the image, we will be going through this process called histogram processing. So histogram processing is known as plotting the graphical representation of an image with number of pixel versus intensity, each intensity value or level. So there are three types of processing inside the histogram. First one is histogram equalization, and second one is specification called histogram matching, and third one is called local enhancement. So histogram equalization is the technique or a processing methodology which is being widely used in digital medical image processing for analyzing or for capturing the data without any loss to understand the data which is being captured by the medical image processing machines. Okay. Histogram of a digital image with gray levels. Gray levels are the intensity level of a plot where it can be in negative as well as in positive. By its level shades, gray level will be adjusted, and gray level will be acting as a property or a feature of an image which is being captured as a medical image. And according to the value of a gray level, discrete function will be decided by the histogram in digital image. So for finding the discrete function, this is the formula: h of r of k is equal to n of k. First, we have to know what is H. H means processing image called histogram. H means will be representing the histogram processing. RK will be the gray level of the image which has been taken as the sample for processing that image. So RK will be denoting the gray level of the image, and NK will be denoting the number of pixel in the image with the gray level. So here comes the key role of the histogram. RK will be the gray level of image which is being processed or analyzed. NK will be the denotion of the number of pixel within the image which is yet to be analyzed, and it will be compared with gray levels. Intensity value will be plotted against the number of pixel. That number of pixel will be plotted along with the gray level value of the image. This is known as histogram processing. And N will be representing the total number of pixel in that old digital image. Total number of rows and columns will be composed to form a single digital image. Number of rows and number of columns will be combined together to form a one single digital image. So the total number of pixel which is being located in that image as a rows and columns will be calculated, and that value will be denoted as n, and k will be 0 to l minus 1, and L minus 1 means L will be the higher integer of the value of a number in the gray level of that image which is yet to be processed. So L minus 1, for example, higher order means 8 is the higher order in that image which is being yet to be analyzed or yet to be plotted in histogram. So 8 will be the L value, and L minus 1 will be the exact value for the setting the limit for the discrete function. So 8 is being considered as a L value means 8 minus 1 will be the 7, and 7 will be the higher order for the discrete function where the image is yet to be processed for the histogram processing. And for normalizing, this is for discrete function of histogram level in a medical image. And next one is normalized histogram, which will be replaced H with P. P of Rk is equal to Nk divided by N. Again, P will be for processing the image with a normalized histogram, and previous one was histogram equalization, and this one was normalized histogram, which will be replaced by P, and Rk will be same the gray level of that image which is having multiple gray level values which will be plotted according to the rows and columns of the digital image, and nk will be the number of pixel which is being gathered in the digital image by which will be calculated by the number of rows and number of columns which is being mingled together to form a digital image, and it will be divided by n, which is known as total number of image. This is the difference between histogram processing discrete function and normalized histogram. There you will be processing according to the value which is being obtained from the image, but here you will be dividing it. Whole summation will be divided with the total number of pixel which is being actually located in the processed image, and you will be getting all component sum will be 1. Why? Because we have been dividing, so this component doesn't have the ability to be in negative shade, so it will be only in positive. So summation of all components in normalized histogram will be 1. But in histogram processing for discrete function, it may have in negative value also. Why? Because according to the higher order byte which is been located in that digital image only, the discrete function can be plotted. So for normalized histogram, it will be sum of all components will be 1 and positive. And this is the formula for histogram equalization. I already told histogram equalization is a method which is being widely used in medical image processing and digital medical image processing application. For image processing, we are using pattern recognition principle tool for process the image to get the clear cut and detailed data from the processed or acquired image. So histogram equalization is the methodology which is being widely used, which is being considered as a procedure for decoding or for extracting the or for extracting the details or data from the image detailing without any error or without any hidden layers. It will be processing and will be giving the clear cut information of the processed image. So this is the formula for histogram equalization to process a digital medical image or digital image. Sk is equal to T of Rk is equal to summation, where it will be limit starting from k0 to k, and k will be the higher order bit of the image which is being processed, and summation into nk divided by n, which will be equal to summation of, again, k will be starting from 0 and higher order will be the value of k, and p of k into r of k. both this both these formulas is being combined with the gray value limits called k in histogram equalization, that is known as the formula of histogram equalization. Again, I'm repeating, this is the formula for the histogram equalization, and by proceeding with this formula only, you can acquire the information of medical image or a digital image with the graphical representation. This is the formula is being used. Sk is equal to T of Rk is equal to summation k is equal to 0 to k into n of k divided by n is equal to summation k is equal to 0 to higher order k, where pk into rk. So this is known as histogram equalization, and it will be resulting with some same or similar to contrast stretching. By contrast stretching process and this histogram equalization process will be somewhat same and similar, but it has the advantage of proceeding the gray proceeding the graphical representation to the next level without any backlogs or without any gap time interval. It will be automatically proceeding proceeding the given image without any backlogs or without any error. It will be producing the graphical representation of the acquired image. So this is the basic difference between contrast stretching as well as the histogram equalization. Histogram equalization is been widely used. Why? Because it has the advantage of full automation. It doesn't need any manual stimulation to produce the output. Once it has been started and once it has been initiated, it will be producing the output till the image is being completely done with the processing unit. And since histogram equalization is being constructed with the automation, it will be determining or it will be finding the transformation function, where the image which is being processed or image which is being analyzed will be transferred from one image to another image after it is being processed. From old image it will be transformed to new image, where that new image will be having the same uniform histogram with clear cut details. This is the main reason histogram equalization is being widely used for the medical image processing techniques. Again, I'm telling, histogram equalization or histogram processing is being completely constructed and developed by using pattern recognition tool. Why? Because at same time multiple processing or multiple data processing will be done to produce the output efficiently in short time period by fast processing is known as the working methodology of pattern recognition. So for image processing, for image enhancement, for medical image processing, histogram is being used as a technique for making the image to be a graphical representation, and that is being developed by the application of pattern recognition. Okay, now in this slide they are showing some of the results which is being consider as a result after providing the or after performing the histogram equalization by this formula. Sk is equal to T of Rk is equal to summation of k is equal to 0 to k higher order k into nk divided by n is equal to summation of k is equal to 0 k, again pk will be coming into rk. So this is known as automation transformation of old image to new image with uniform histogram values, but with new and clear and explained contents. And so this is known as the results of a sample image before and after histogram equalization, and its gray level will be adjusted according to the contrast. It may be low or high to acquire the clear cut image of a digital image. Contrast will be adjusted and pixel count will be aligned according to the clear cut detail, and by adjusting the pixel count and high contrast or low contrast or adjusting the contrast, a clear grayscale histogram contrast level image will be retrieved. So this is known as the process to find the clear graphical representation in a digital image to analyze the medical therapy or a detection or diagnosis process in biomedical domain. So this process is being done by this procedure, and this procedure is being completely constructed by using pattern recognition working methodology. And this is the simple example through MATLAB it is being displayed. For example, I have taken an image which is being captured by a camera, which is not having a clear cut image or a clear information cannot be accessed. That image yet to be processed will be plotted in MATLAB. By using MATLAB, it will be processed and plotted as a graphical representation, which will be plotted against pixel value as well as a desired intensity value, which is known as gray level value. And after once it is being plotted, it will be applied with that histogram equalization formula as k is equal to t of r k is equal to summation k is equal to k into n k divided by n is equal to summation of k is equal to 0 to k into pk of rk. This formula will be playing the role for converting the normal input image into the new output image with clear information and knowledge. Now we will be seeing it. This input image, after applying that histogram HE's formula, it will be plotted as output image with adjusting the pixel count as well as contrast of that image. The contrast level can be higher or lower according to the need and demand of the output information. Contrast level will be aligned and the output will be produced. So for output image will be plotted again as a histogram. Histogram will be having uniform counts and uniform placement or uniform plotting, but its value will be differing according to the processing of the histogram equalization formula. So this is the result before and after image of histogram equalization processing. Like this only, medical image like a CT, MRI, X-ray is being used for extracting the data clear and depth for diagnosis and detection or for selection of the therapy to given to the patient will be decided by after using this histogram equalization process, which is being done and developed and constructed by pattern recognition applications. And it will be working according to the intensity level, gray level, and there will be a transformation where input image will be transformed to the output image with the clear information and knowledge of the exact input image will be transformed. First, this process is being completely plotted according to the histogram equalization, where the original histogram will be plotted for the given input image, and that histogram equalization formula will be applied on the given is input image, and the transformation function and equation will be happening. Once the transformation function is being completed, it will be producing the output. That output will be equalized with the histogram, where it will be having the same histogram but with clear and more perfect and more knowledge content can be derived from the output. So like this only histogram will be having its working and transformation and equalization process. So I already told for histogram equalization, image will be transformed according to with the graphical representation which is being plotted in a graph with its gray level as well as its number of pixels. By adjusting the gray level and number of pixel only, histogram equalization will be using the transformation of input image into the output image with more knowledge. And in this video, I have been explained how the pattern recognition application is being used for image processing unit application by its working methodology called histogram and histogram processing. In that, we have been shown the histogram equalization methodology and procedure. Thank you. Here I have been explained about the application, working procedure, and how it is being done in digital medical image processing by using the pattern recognition application. Thank you.